Hi, everyone. Welcome. Thank you for joining another DevTest Community Webcast. Today we're covering DevTest for performance testing. We have Surya on the phone today. He's given quite a few community webcasts before, so you guys are in good hands for the presentation today. If you have any questions as we're going through today's session, you can feel free to enter them into the Q&A box in the bottom right-hand corner of your screen. Or if you'd like to ask an audio question, you can hold those questions until the end, and we'll let you know how to unmute yourself at the end of the session. I know that there's some issues with intercall today, so if you're having trouble dialing in, the best bet is just to put your questions into that Q&A box, and we'll get to them when Surya has a pause and respond to those at that point. All right, so let's go ahead and get started. I'm going to turn this call over to Surya now. Take it away.
Thanks, Melanie. Hello all. I'm Surya, and I'm part of the CDBU here at CA. So we deal with DevTest and host of other continuous delivery related products. I'm part of the customer advocacy team where we help customers with upgrades, issue resolutions, and architecture recommendations, etc. So today we'll talk about the DevTest for performance testing. Now I'm sure most of you have performance testing teams within your organization, right? So the agenda basically today would be to talk about application performance and performance testing. We'll talk a little about DevTest, application test and service virtualization. We'll talk about using application test for performance testing, then performance test and service virtualization, then benefits, and we'll quickly go over a few items in demo and then the Q&A. That'll be the agenda. As we were talking, so application performance is, I'm sure most of you have application performance function within your organization, and it is very critical to organizations and a vital function, especially now in the application economy where everything is driven by software, and applications or software is the first point of contact with customers for most of the companies. So it sort of becomes like the face of your company, and companies are under pressure to release applications faster to make sure that the functionality reaches customer faster because the consumer demand is more. So companies are taking to agile and rapid delivery, and they have shorter release cycles, making it even more difficult to achieve the required performance test goals and to include performance testing in that shorter release cycles and achieving the level of performance testing that they need. And the customer expectations are also changing. Customers expect faster load times. Especially there are some stats where if your mobile application takes longer, like than 2 seconds or 3 seconds, customers will be unhappy. I mean, imagine you want to search for something on the internet, you open your mobile phone, and let's say it takes 5 seconds or 10 seconds to load. Obviously, you'd become impatient. Even I will be. So, the customer expectations are changing, with faster bandwidths, and they're expecting faster load times. So the performance of your application becomes very critical. And the applications of today have numerous dependencies. They have a lot of third-party integrations. So it is not just dependent on, what you have. I mean, you're also integrating with a number of other third parties. Like, for example, let's say, you do a mobile check-in, so you have the Google API coming in. So there are a lot of APIs that the mobile applications are interacting with. So it becomes even more critical to, make sure that, your performance testing, your application performance is good. And it makes it all the more difficult to test the performance because it's, you have dependencies on third parties, so it becomes all the more difficult to do performance testing. So we will talk about all of this and more as part of this presentation. So how does performance testing typically happen? In a typical scenario, very few developers actually performance test their code. There are some stats to even, verify this fact, which is actually, problematic. So most of the developers, they develop the code and push it, and they think about performance testing later in the release cycles. It's done very late, probably after your QA is done and all that. That is when you think about performance testing, probably a few weeks before your release. So that's actually, typically performance testing is done late, and it's more often than likely not done by the developers. And the tests are also scaled down. The challenge being the infrastructure in your prod would be scaled to obviously to support your production demands, but your environment where you want to do your performance test the performance is not scaled to the level of your production. So you obviously run scale down tests where you run with limited load, and it's not actually a true prod test that you do, right? And and also scenarios, the testing of scenarios is limited because of multiple challenges. It can be a constraint where a certain system is down when you want to do performance testing, or it can be constraints where the third parties do not support performance tests or load tests. So there can be multiple challenges due to which even the number of scenarios that you test become limited. So the test coverage is also limited for your performance test. So these are some of the typical scenarios we see. And the outcomes being timeline slippage. So when you actually end up doing performance testing late, you would probably have limited time before your release, and then you have these challenges that come up where a system does not respond, or there's some maintenance, or certain system does not participate. So the problem is that your timeline slip. You obviously end up extending your performance test timelines, and timeline slip, and that costs you money. And also design changes. Now this is another thing. So let's say you identify a performance issue late in your release cycle, and you realize there is some design flaw, and if you want to make a change in the design, now that would also cost you, right? So design changes, or whatever performance issues, if you discover them late in the cycle, that can also be a challenge. So you end up releasing code with exceptions, again, in some cases. So that is actually a challenge. And poorly performing code, I mean, if you have not actually tested the performance completely, and if you release it, what happens is, you get these performance incidents in production, and, you end up providing poor customer experience, which is not acceptable. So, your approach becomes more reactive rather than proactive, right? That's typically the outcome when, typical outcome. So these are some of the challenges. Let's talk about, so we will definitely talk about how we can address these challenges. Let's talk a little about DevTest. So DevTest product suite comprises of, application test and service virtualization. So application test helps you drive headless tests. It can be an API test, or it can be a web service, it can be our MQ service, but you can actually drive headless tests. So that is, using application test. And service virtualization, where does that come into picture? So it helps you eliminate constraints. So you want to test your application, but the application integrates with a lot of systems and a lot of third parties. So there are numerous dependencies. So each dependency is a potential point of failure. So let's say if you want to run your scenario, but one system is down, now that would make it challenging for you to run your scenarios. So such constraints can be eliminated with help of service virtualization. So you can virtualize the services that you need for your testing. And if a system is either down, or if it's not performing, if it's not available, you can always use virtual services in place of the system, and you can run your test. And we'll talk a little about component-based testing and all that as we go through the presentation. Now, this helps you get an always-there environment. So your environment downtimes can be minimized by using virtual services. And you could do your end-to-end scenario testing or your performance testing, all of these kind of testings by using a combination of app test and service virtualization. So this way you're eliminating your upstream and downstream constraints. So upstream constraints may be where your application is still under development, and if you want to do the testing, you could use app test to drive headless tests. So you can test your API, or you can test your services, before even you have the UI or any other constraints, right? So you can eliminate those. And downstream constraints, as we discussed, service downtimes or service unavailability or expensive to use or costly third parties, you can eliminate all those constraints by using virtual services, by service virtualization. So this way, application test and service virtualization helps you eliminate upstream and downstream constraints. How can we, so application tests for performance testing. Now I tried to put together a sort of a flow here. We'll go over that. So application test helps performance testing through load generation. So using application test, you can generate load. So through a component called simulators, it actually can generate, has virtual services and virtual users. So using these virtual users, you can generate load, and this load can be used to test, an API or whatever you want to test. So you can do load generation using simulators. And we have the coordinator, as you see here, it orchestrates the test runs. So, okay, simulator would actually do the, would be running the load against the test, and all of the metrics, it will pass on to the coordinator. So the coordinator will collect the test execution metrics, and it will pass on. That way, you can actually get a report at the end of your execution and look at how your systems are performing, right? So that is how coordinator helps. And you can load whatever configuration you need. Using staging doc, you can specify the load. Now, each simulator out of the box supports up to 256 virtual users. Now, if you want more, you can add multiple simulator instances. You can spin up multiple simulator instances and generate the kind of load you need. And you can do your load generation and do the performance testing against an application. It can be a headless test, or so you can actually do the load generation using application test. Now let's talk a little about performance testing and service virtualization. So in order to support performance testing, you need CA service virtualization for performance. So the regular CA service virtualization that you get can only support up to a maximum of 10 transactions, 10 concurrent transactions. But if you want to actually do a performance testing or load testing, you would want to drive a much higher load. And in order for your virtual services to support that kind of load, you need CA service virtualization for performance. So the performance, that would actually help, support the kind of load that you need. So here, as you can see, the application interacts with a number of, other systems, right? So if you're trying to test, like let's say the ESB layer here, right? So, you can actually eliminate any constraints here. So for example, let's say you have any unavailable systems, you can virtualize that system and eliminate that constraint. Or if you have third-party systems which do not support performance testing, you can virtualize that. Or if it costs you per transaction, you can virtualize that. That way, you can save the cost. And you can also simulate scalability of systems. Now, virtual services are pretty lightweight in the sense that they don't actually have to perform all of the functionality, the actual functionality which is done by your SOR or the systems. So that way, the scalability is just limited by how much hardware you have, right? So you can scale the virtual services and make sure that it supports the load. So it can stand in place of the real service, which cannot, let's say, scale to the level of testing that you need. You could actually use a virtual service in place of that to, to scale up and support the loads, for you to perform test. And you can do a prod-like test that way. And also the data needs. Now, if you want to do a load test for, let's say, thousands of users, so typically, you would want the data set up, right, for thousands of users, and you would run through that. But through a combination of magic string, using virtual services, you can set up some limited data scenarios, and it can actually, since here, again, so one point to consider here is for performance testing, you're not really validating the data, you're validating the performance. So there, a virtual service can provide you the, support the data needs of your organization by, handling the different requests that come in through a combination of magic string. It can provide the responses that you need for all of the different inputs. Like it's thousands of users. Let's say you want to test so different records. So it will actually support your data needs. That is another thing. So how do you achieve the scalability? So the scalability, again, has multiple factors. Just to highlight a few, one of the scalability factors is setting the capacity, the right capacity for your service. So for your service, the capacity basically determines the number of requests that it can process. So by increasing the capacity of a virtual service, you can make sure that it can actually support heavier loads. Then the memory allocation. So in addition to setting the capacity, you want to make sure that your components like virtual service and your VSC has appropriate memory allocated to support the load and processing. So once you have appropriate memory, it can actually also process these number of requests, concurrent requests that come in. And also the appropriate log levels. So the log levels, if you typically the default is info, right? So which generates a lot of logging. But imagine if you have a huge number of transactions that are coming in, you wouldn't want to log each and every request, right? So you can change the logging level to 1 to make sure it logs any issues or defects that, any errors that you have. So that way, by minimizing logging, you're reducing the load of the system, and the system performance can scale up to your requirements. So these are few of the considerations. You want to make sure all of these considerations are met before you do a performance test to make sure you get optimal performance using service virtualization, virtual services. So what are the benefits? So the benefits are shift left of performance testing. Now the reason why you typically do not perform a performance testing, let's say in development phase, typically is that the systems are unavailable because the systems are either undergoing build or testing. So that way you are not able to perform the performance testing because if you want the end-to-end test, basically if you want to do a test, typically what you do is you just perform an end-to-end test for all of the systems. But you can do a shift left where, let's say a team develops a component, you can performance test that particular component by virtualizing all of the other dependencies. And by using virtual services, even though your dependent systems are under build, you can put a virtual service to stand in place and do some level of performance testing to make sure that your component you are building is actually performing well. Now that actually ties into component-based performance testing. So this is where in your application flow, you can pick up any component in the flow, and by virtualizing all of the dependencies that it has, you can do performance test on that particular component to make sure that the performance of that system is up to the requirements. So for example, let's say you have a portal and it interacts with 10 different systems. By virtualizing all of those 10 different systems and making sure that setting the appropriate SLAs or response times for those, you can measure the performance of your application and see if there are any performance issues. So that is a component-based performance testing. Now shift left of performance testing will help you identify defects early on, any performance-related defects early on. Therefore, if you have to make any changes, you can do it early on and don't have to wait until end of your testing cycles, and then you don't have to again move back through the release cycle. So that way you can identify performance issues earlier, which will help you move better performing code into production and, to the customers. Then another advantage is, I know we have discussed this in the last few slides, scalable performance tests. You can do production-like tests by making virtual services stand in place of your systems and making sure they perform, up to your production requirements, in terms of the load support. Then complete test coverage. So you no longer have to stop testing a certain scenario because a certain system is not available, or a certain system is expensive to use, or a third party which does not support performance test. You don't have to worry about those. By virtualizing those dependencies, you can test through all of your scenarios and make sure that the performance is up to the mark. Then cost savings, of course, by virtualizing third-party systems, you don't have to pay per transaction for them, and any of your, and through this, you don't have to rerun your tests a lot because the behavior of the systems are pretty much stable. You could run through your performance test or load test and measure the performance, and this also helps, in reduced cycle times. You don't have to do a lot of reruns, so that is another advantage. And also another thing is, you may also want to test negative scenarios, like, for example, how would my application behave if the service were to respond slightly slower? Let's say in a peak day, let's say if the service, let's say, it responds slower, how does the application adapt to that? So you can do that by changing your think scale, your service response times. You can change them on the fly and test how would it be if it were slower, how would your application behave. So these sort of negative scenarios also, you can test. And, error scenarios, of course, using virtual services, you can actually make sure, you send a negative error response, let's say, and look at how your application behaves when something like that comes up. So multiple scenarios you can test by using virtual services. You can simulate those. All right, so let me quickly run through a few things that we discussed. Just bear with me, I'll share my screen.
Surya, while you're doing that, we do have a question in the Q&A box. I can read it out to you now if you have a second.
Sure, Mandy, yeah.
Okay. The question is from Patrick. Service virtualization sounds great for functional testing, but for performance testing, how do you ensure and provide data to devs that the response time isn't impacted by VSE? There is a console with graphs, but it plots total data and not transaction logs.
Okay. So, in terms of the response times, right now, with our virtual services, there are definitely, if you look at the virtual service metrics, there are a lot of reports that we have through which, it can provide you the average response times and, the load, the TPS that the service, was being hit with. So this will help understand, validate, in fact, if the load that is being generated is actually getting translated into your service. So you could look at the virtual service load, that is one thing. Then the response time, you could look at the average response time, metrics from the virtual service reports. I'm not sure which version you're using, but definitely it has improved a lot with the newer versions. So you could look at those metrics and provide that. Now, in addition to that, your organization may have, an application monitoring utilities, like let's say CAPM. So you may have some monitoring utilities through which also you can look at the response times. But yeah, there are a lot of ways through which you can actually monitor the response times. That's the thing. So let me quickly just a second. All right. So let me share the screen. So we will, Melanie, are you able to see my screen?
Yeah, it looks good. Thanks.
Wonderful. Okay. So we'll look at, I'll walk you through a few of the items that we discussed as part of the presentation. Now, one is load generation. Now, we did discuss about load generation, right? So typically, we have the staging dock where you can specify the load that you need. Now, there are different load patterns that are supported. It can be run some n number of times, or you have a manual load pattern where you can define the load pattern. You can immediately ramp, or you could have stage steps where you define incremented load pattern. So there are different load patterns that you can select. In addition to that, you can actually define the number of instances that you'd like to test with, and you could also define a test duration, or you could also provide test spacing. If you'd want a certain number of executions within a given time, you can mention that here. You could pace the test accordingly. And distribution of the load, again, so we have simulators that provide the loads, right? So you could, and execute the test. So you could actually distribute the load, among the simulators. There are multiple ways in which you could do that. You could have percentage distribution where, let's say, in your simulators, you would want, instead of, again, by default, it's auto distribution, so it will distribute the load. But let's say you'd want, certain simulators to have more load than other simulators. You could adjust the percentages here if you'd want to do it that way. Or you have the round robin distribution, which will just round robin, it will distribute using that, it will distribute the load across your simulators, or it can also be based on instance capacity. So you have these multiple options of distributing the load. That is one of the things. And now reports. Now as part of your testing, reports get generated. So default report generator, again, it captures a lot of the information, a lot of metrics, which is useful if you're doing functional tests. But let's say if you're doing a load test with heavy loads, it would be a lot of DB calls, and it would provide a load on the system. So for that, what we have is a load test report generator, so which would provide not individual step level metrics, but it will provide you the load metrics, like the average time that it took for a particular step, what is the transaction time, etc. So all of those metrics can be captured as part using load test report generator, and also it will have less load on the DB because of the number of calls it will make to the DB will be more limited, and that way you could achieve better results. So that is a load test report generator, and there are of course a few other report generators, XML report generator, but typically for load test the recommended methodology is to use the load test report generator. Now that is one thing, and if you'd like to use IP spoofing, we have that facility. If you'd like to use IP spoofing, that's another thing. So using this, this staging doc, you mentioned the load details that you'd want to generate, and whichever test case you want to stage, you could just a second. You stage a test, and then you can specify the staging doc that you'd want to use, and you could specify the coordinator server that you'd like to use to run the test, and you can stage it, and then depending on the number of simulators you have, the coordinator will distribute the load accordingly to all of those different simulators that you have. So this is in terms of the application test, and of course you have number of reports like average response transaction times, etc., that you could actually look at, testing reports, and you could that will help you understand the load that got generated, how the application performed. In addition to that, let's quickly look at some of the other things. So if you look at virtual services, now in order for your VSC to support the performance in the sense to support larger heavier transactions, more than 10 transactions let's say per second, you'd want to have this property set in your local properties file, which is Lisa VSC performance enabled true. Now for this you need the performance license. If that is there, you could actually enable the performance on your VSC performance mode, and this will make sure that it can support heavier loads. Now it is only limited by the hardware and the memory allocation that you have. So it can actually support a lot of load that way once you enable the performance mode. And login properties, we spoke briefly about that. By default it's info, but if you look at it, the root category logging and the VSC logging, by default it's info. The recommendation would be to change it to 1 to make sure that it does not log each and every transaction that comes in, but rather only in case if you have some errors, it will log those, so you can review that later to see if there are any errors, and you can resolve those. So that would be one of the other recommendations. And let's quickly take a look at the VSC console. So if you look at the VSC, like I have one virtual service running. So here it will provide you information on the transaction count and the current transactions per second and the peak transactions per second. So let's say when you run a load test against the virtual service, you could look at what the current transactions per second is and what is the peak transactions per second that came onto the virtual service. Of course, we have reports where you can view that also, but I'm just providing, on a fly during runtime, you can check here. And if you look at it, we have the capacity. Now this determines the number of transactions, the kind of load that the virtual service can support. So you could increase the capacity to a higher value. If you have a performance mode enabled, you could increase to whatever value you want. Like let's say for example 50 would be the capacity. You could set that, and you can just save, and that way it can support more load. depending on the incoming load. So, but setting the capacity to the right value would also be critical to make sure your virtual service supports heavier loads, and the response times are basically what you expect. And we have the think times and think scale. Now, think scale really is how much is the, so for example, let's say your virtual service response time is currently, let's say it's set to, think time is set to 1000 milliseconds. So that would mean your virtual service responds within 1 second when it gets the request, right? So if you want in runtime to make sure you double the response time, let's say, and see how your application behaves. So you can change the think scale from 100 to 200. So that way it will double the response time. And this can be done on the fly. You can update this on the fly and it will double the response time. And if you want the response time to be half of what you have in the think time, you can change it here. So typically, the think time values, when you're doing a load test against virtual services, you want to make sure you mimic whatever the SLA that you want. For example, let's say your prod, let's say your service takes 500 milliseconds. You want to make sure that is what you set as the think time to replicate or mimic the production behavior of that particular service when you use virtual services. So that way you have a more accurate test, instead of just putting 0 and So your idea is to make sure your virtual service emulates your production services behavior in terms of the response to measure how your application would perform, when let's say your service responds within 500 milliseconds. So that is another aspect of think scale and capacity and in terms of the memory allocation, let me quickly run through that. So your VM options is where you can define the memory allocation. Now, if you have a large number of virtual services for your performance testing, and if each of them are taking again a lot of if you're sending in a lot of transactions per second to each of those services, you want to make sure that you increase this number. So you can monitor the memory usage either through the health monitor, or you can as such monitor the memory usage of your processes. And if you see that it's going high, I would you recommend that you can increase this value so that the virtual service VSC component has enough memory to process all of the different requests that come in. So this is another key aspect that you'd want to look at when you are setting up virtual services to support performance testing. And of course, we spoke about response times. So think times right here. So you can change the think time specifications and make sure that virtual service meets your the response time requirements. So this is basically, I just wanted to run through what all we discussed as part of the presentation. I just wanted to show them in the portal and workstation. Do you have any questions based on what we have discussed so far? Feel free to put them in the Q&A section and we can definitely discuss.
Okay, any questions, guys? There's a Q&A box in the bottom right-hand corner of your screen. We'll give it a few seconds to wait for questions to come in. Surya, do you have anything left to present?
No, that's all, man. I can take the questions.
Okay, great. Also, if you do have any questions you'd rather ask over the phone, you can click #6 on your telephone keypad now to unmute yourself to ask a verbal question. I did get a question into the chat. Can we have this deck? Yes. So I'll be posting a PDF version of these slides along with the Q&A transcript and the recording to the community later today. I'll send that out in a thank you email to all of you guys, and also I'll comment on the original event with a link to that. Okay, and we have a question in from Rajesh. Thanks, Surya. Do we need any plugin for simulating virtual users load?
No, so the virtual users are generated using simulators. Like I said, each simulator supports out of box up to 250 transactions, 250 virtual users, and you could actually spin up multiple simulator instances to generate the kind of load you need. So simulator can, generate virtual users in terms of the load. So you don't need to use any other plugin for that. This is if you're using an app test to drive the load. Some organizations have other tools like load runner to drive the load. Then, you need to make sure, you have the virtual services to support the loads. Again, this is if you have any, to make sure you don't have any constraints with the performance test.
Okay, any other question, guys? Once again, that's the Q&A box in the bottom right-hand corner of your screen, or you can click #6 on your telephone keypad to unmute yourself if you'd like to ask a verbal question. Okay, another question in. Does it integrate with any other performance testing tools that are commonly used?
So again, performance testing tools, so virtual service is just like your, your real service, right? It can stand in, for example, if you have a web service and you're using a virtual service, you have a URL, right? And you could use that for doing performance testing. So you could use any performance testing tool to generate the load, on your application or performance, to performance test the application. But you just want to make sure that instead of your real services, if any constraints are there, you could use virtual services. Or if, let's say, you're doing component-based testing, you make sure all of the URLs inside, dependent URLs or queues are all replaced with virtual services. So that way you could do, your component-based performance testing. So you could use any performance test tool to drive the load, but virtual services can stand in and provide the support for the load that gets generated.
Okay, we got a few more questions coming in. Can we increase the number of transactions shown in VSC Inspector for a service?
Okay, I do not have that property right on top of my mind right now, but there is a way, you could actually increase that. I'll probably, get back on that. Or you can post this question on the communities and I can answer that. But there is a way. I don't have that property right on top of my mind, but I can help you with that.
Okay, thanks, Surya. And a few more questions coming in. In the demo, we did see how we can consume SV and do performance testing. In the demo, did we see how we can consume SV and do performance testing for API/services using application test?
Okay, so I did not actually run through the actual process, but if you'd like to do that, it's you can always, let me quickly just bear with me. Okay, so let me answer the other questions. In the meanwhile, I'm running a test, so I'll show you. Okay.
Okay, so while we wait on that, we have a few more questions in. One of those questions is, if we need 1,000 V users and since each simulator supports 256 users, do we need multiple simulator services pointing to a common coordinator, or how can this be done?
Right, so you could have, let's say if you're 1,000, you could have 4 different simulator instances. And you could have a single coordinator which can actually coordinate the distribution of the load. So, you could stage the test using that one coordinator, and that coordinator would have 4 simulators at its disposal, and it can distribute the load accordingly. So, yeah.
Okay. Can VSC virtualize HTTPS out of the box?
Yes, we can virtualize HTTPS, single one-way or two-way SSL services. We can virtualize that using VSC. You can expose HTTPS services using VSC. We can do that. Okay, so I'll quickly share my screen to show the load generation that I'm doing right now. So what I'm doing now is, I have the cars baseline test right here. So this test I'm executing, and I have a virtual service, cars virtual service, which is supporting on port 7000, which is supporting the load. So now the test is running, and so the load I'm using is 50 instances. I'm running for a maximum of 1 minute. Again, just to showcase, it can be any load basically, right? So, and accordingly, you have to make sure the settings are there. So I have that, and I have a virtual service already running, and as you can see, the transactions are coming in, and the load is coming in, and I have set some capacity and some memory allocation. And if you look at the information right here, you could see the peak transactions per second has gone up to 78. The current transactions per second is 41. So it will vary a little, but you could see the average TPS ultimately, and you can see that information to help you understand what is the TPS that is coming in, the average response time. So all of that, you can get that information. So yeah, so this is basically how you could execute. I think the test has ended, but really, you can point your API test. Again, this is an API test. If you look at it, it's triggering the cars API calls. Most of them are GET calls. I think I have a couple of POST calls here, but pretty much, you're using these API tests to trigger load against the, you'll be getting a response like this. So you're testing this against the virtual service, and this way you can actually do a load test against virtual service. I hope that answers your question. Now, if you have a specific scenario that you'd like to discuss, feel free. We can definitely discuss on that. But this is basically how you could, just a simple example, just to show you how you can generate load.
Okay, thanks, Surya. And I think that's all the questions for right now. So what I'm going to do right now is I'm going to launch a poll. If you guys could please vote on the poll and let you know what you thought of the topic today. We like to get your feedback and use that to plan future topics. If you have any questions that you think of later on, you can always go ahead and enter a question into the communities. We have people constantly monitoring the communities to make sure to get you guys quick responses. So you can feel free to do that, or you can comment on the webcast recap that I'll be posting with the recording later today. All right, other than that, if there are no other questions, thank you so much, Surya, for another great presentation. Thank you, everyone, for joining, and I hope to see you all out in the communities. Have a great day, everyone.
Thanks, everyone.